All right, so in Calculus 30, we're in section 3.5 in our Red Stewart textbook. This is question number 11. We're talking about related rates, okay? Related rates. So in these types of questions, you have usually two rates of change, okay? So that's two derivatives that you're dealing with. So let's take a look at this question. It says a ladder that's 4 meters long rests against a vertical wall. So I'm just going to draw that. I'm going to draw that situation here. So we have a ladder here. This is my ladder. And get some rungs there. So this ladder is 4 meters long, okay, from the bottom to the top. And it's resting against a vertical wall. So this is 90 degrees right here. It's a vertical wall. We'll assume that the floor is totally flat and it's a 90-degree angle there. If the bottom of the ladder slides away from the wall at 30 centimeters per second. So here's the bottom, and it is sliding away at 30 centimeters per second. So this is a rate of change of this dimension here. So this dimension right here, let's call that x. So x is changing at 30 centimeters per second. Okay, so I'm just going to jot that down. This is randomly just arbitrarily x. Okay, that's the rate of change of x. How quickly is the top of the ladder sliding down the wall when the bottom of the ladder is 2 meters from the wall? Okay, so the top of the ladder here is sliding down the wall. You see that? And so we're going to have to come up with a variable for this height right here, and let's call that y. Okay, so y prime, how quickly is the ladder sliding down? So we don't know what y prime is. You see? We don't know what that is. So what we need to do is we need to find out how this length and this length are related given the nature of the situation. And of course, I hope that you see that we have a right triangle here. That's y, that's x, okay, and this hypotenuse is 4. So I can make an equation here. X squared plus y squared equals 4 squared, right? X squared plus y squared equals 4 squared. That's a squared plus b squared equals c squared. That's the Pythagorean theorem. All right, that's great. Now, we do need one more thing to note here. When the ladder is 2 meters from the wall, so that is, we did let x be the distance from the wall to the bottom of the ladder, so this is at x equals 2, all right? Okay, so let's go ahead and see what happens here. Let's take the derivative now of this whole thing with respect to time as the ladder is slipping away, right? And all that really means is that neither x nor y are the preferred variable, so the derivative of x is not 1, it's x prime or dx dt. The derivative of y is not 1, it's dy dt. Now I like using Leibniz notation, so that's just simpler for what I normally use, so let's just take the derivative of everything here. So that turns out to be 2x times x prime plus 2y times y prime equals, what's the derivative of 16? Well, that's just 0, isn't it? Okay, so we've got this, and now look at what I have. I have x prime right here, which I know is 30. I have y prime that I'm looking for, so this is what I want to solve for. Now, I have x, that's 2, but I don't have y. So you are going to need to figure out what y is also at this point, which actually is pretty easy because watch what happens here. If I just let x equal 2, I can easily find out what y is at this moment in time. So 2 squared plus y squared equals 4 squared. Y squared equals 16 minus 4. Y is root 12. Okay, or so. So y is root 12. So now I have y. Okay. So whether you want to isolate for y prime first or you want to plug these values in, doesn't really matter. So I'm going to isolate for y prime. Oops, y prime. So what's that going to be? That's going to be negative 2x x prime divided by 2y. Okay, when I get that all together. So y prime then is negative 2 times x is 2. X prime is 30. Now we have to be careful here. X is increasing. Y is decreasing. So yeah, we have to kind of pay attention to that, right? Because it's the length of y is getting smaller, so that's going to translate to a negative. So I think it's going to take care of itself here, but just watch here. So I've got over 2, and y we said was root 12. You can write a decimal there. It's always best to do exact answers though when we can, right? So what do we have here? Y prime is, that's negative 4, sorry, that's negative 120 over 2. That's 60 over root 12 or so. 60 over root 12. Now, a negative, I should say. So, you can leave that as your answer, actually, if you want. But we could also just check that out, what that is as a decimal. So I'd be interested in that. So negative 60 divided by the square root of 12 is negative 17.32. So negative 17.32, and of course we're gonna have to kind of look around here. I noticed something. 2 meters and 30 centimeters. Okay, so this is why units are pretty important. We're going to want to make sure we pay attention to that. Why? Because look at what I did. I substituted. So this is in meters. So this is going to be in meters. This is in centimeters per second. Big trouble. Okay, so I just got to back up a little bit. No problem. And if this is you just have to kind of fix some things here. So 30 centimeters is actually 0.3 meters. So we have to make sure our units line up. So that's going to be 0.3 right there. So you can just add that. And so then what happens there is we have 2 decimal places. So that's going to be something like this. Negative 0.6, I guess. Right? And so what will that do? Well, that'll just move our decimal place over a couple points. So that's going to be negative 0.1732. Negative 0.1732. And of course, these are now all in meters and seconds. So that's going to be meters per second. Okay. So again, if we think about this, the ladder is sliding away at 0.3 meters per second. Okay. And that's the bottom sliding out, and the top is sliding down, that's why it's negative, at 0.1732 meters per second. So the bottom of the ladder is sliding away quite a bit quicker than the top of the ladder is. And if you can envision that, that might seem reasonable, because the bottom is sliding away quite quickly, but the top is just kind of coming down a little bit slower. Okay, so we're going to double check our answers here before we conclude. So yeah, the answer is confirmed, 0.17 meters per second. You can just round it to 2 decimal places if you wish. But yeah, that's the answer to number 11 on 3.5. Just make sure your units line up, centimeters, meters. I missed that, but we did catch that before we were done. So you always want to double check that at the end.